For my project, I tried to predict Parkinson's disease probability from patients' health data. This project would be like a remote way for doctors to identify patients with a higher risk of existing Parkinson's disease by using maybe like internet surveys or phone surveys and contacting risk patients or their relatives remotely. And I used Orange for different classification models to choose the most suitable for identifying potential patients. So the dataset overview, I used a data source from Kaggle, which is actually a really nice place to find data sets to play with. So thank you for sharing that. And there were a bit more than 2,000 patients who were tested for Parkinson's disease. And the results were both positive and negative. So I used this feature to run the models on whether the patient would be positive or negative based on other input data. So the full data set included a lot of demographic details and lifestyle, medical history, as well as clinical measurements and cognitive and functional assessments, symptoms, and of course the diagnosis indicator. But I chose to use in this research only the details that can be assessed remotely. So by surveys, by phone, or by internet. So these are the variables that I used. I'm not going to read all of them, but basically it's demographic details, the patients aged from 50 to 90, as well as lifestyle factors, medical history, and some indicators like tremor, rigidity, etc. This is how I went through the process. This is a screenshot from Orange. I did try some of models and tried to like play with them and see what different results I might get from using different settings in the models. And so the best thing that I got was a tree with 71% accuracy. I also tried, did not include it in the presentation, but I tried to see what accuracy I could get if I was using also the other features that have to be like assessed in person, like some blood test, etc. And the highest score I could get was above 80. So the difference was actually not that large. And so the result that I got, the best one was the tree model. And as you can see in the confusion matrix, a thing that I thought was really good was that even though there were quite a lot of negative predictions, most of them were false positive, not false negative. So if a person is diagnosed incorrectly, it mostly is false positive. So they would still have to go and run some tests. There is the tree visualization. Here you can see the most important factors that impacted the decision of the research. The first one would be tremor. And if a person has tremor and rigidity, and then you can see the whole right side is basically a lot of factors that might impact the result. So here I did little like tests on 10 data points to see what the accuracy would be. And the accuracy actually was, as expected, the 70%. And 7 from 10 predictions were accurate. And here you can see that the 3 inaccurate predictions were also false positive, not false negative. So yeah, For me, this was like an interesting way to see if this would actually work with the remotely accessible data. And I think it actually would be like a good first step to remotely assess patients for doctors, and then forwards to see if they need to be sent to more like tests, or they have to come in person. And so I think this could help people who are not going to doctors, but assessing them online would be like a bit easier, and maybe would cover a bit of a broader audience.